So welcome. So apex has gone down. It's okay. Okay, fine. Okay. Linear algebra relates to linear equations. Okay, so linear equations can be in this form, correct? A11 x1, A12 x2, A13, where A11s are the constants and x1, x2, x3 are the variables. So we have x's x1, which is the variable which comes everywhere, x2, which is a variable which comes everywhere, like that, and equal to some constants here, which does not have any. This is x raised to 0, or this is a constant. Constant also comes over here. So this is a general equation in which a system of linear equation can be done. So linear algebra relates to solving this system of linear equations. Yeah. So these equations can be written in this form as a matrix form. So what is matrix? Matrix is system of linear equations. That's it. Correct? So next, okay, I think Ajay did not come. Is it not? So what is matrix? Matrix is a rectangular array of m into n numbers arranged in m rows and n columns. It can be written in three ways, obviously. Correct. So this is one of the things. Now one of the thing is here a11, a12. That's all simple. Equality. Two matrices are equal if all the elements are equal. Some you can add two numbers, corresponding number. If you add, you get the addition of two matrices. Subtraction, see for example, 3 2 1 5 6 1. B is 2 1 1 3 2 0. Then 3 minus 2 1, 2 minus 1 1, 1 minus 1 0, 5 minus 3 2, 6 minus 2 3, 1 minus 0 1. This is subtraction. Okay, that's how it is. Okay, now here a minus b, if they are not of same order, if they are not of the same dimensions, then you cannot perform this, because these are system of two different types of this one. It's like apples and oranges. You cannot do that. It should have same dimensions. Correct. Next, multiplication. I hope you know matrix multiplication. I don't have to tell you again. I'll skip this up. Okay. Now, one more point in multiplication is the number of columns should be equal to the number of rows. Otherwise, multiplication is not possible. Generally, we write M cross P matrix and P cross N matrix. So this and this should be the same. M is number of columns and P is number of rows, right? No, M is number of rows and P is number of columns. So here number of rows should be equal to number of columns. Here. So this is number of rows. Second, number of columns in the first matrix should be equal to number of rows in the second matrix. So that's how it is. Number of columns in the first matrix should be equal to number of rows in the second. So you can have 2 into yeah. So I think you can do it, right? So yeah. So that is how the thing. See what? How do we write this? We write a11 b11 a11 b11 plus a12 b21, right? So you go like this, you go this way. So number of columns here should be equal to the number of rows, right? So it is rows into columns, fine. So we know. Here, if you see, you cannot multiply these two because this is 2 cross, sorry, 3 cross 2 matrix, and this is 2 cross 3 matrix. This is 2 cross 3 matrix. This is 3 cross. This is 2 cross 3 matrix. So both are 2 cross 3 matrix. So 2 cross 3 into 2 cross 3. I cannot have because these are not same. Make sense? So this is important one. Next, transpose of a matrix. What is columns will be rows, rows will be columns. That's it. Okay, that is transpose. 3 will go here, 4 will go here, 5 will come. So whatever is the row becomes a column. That is called a transpose. So we had that. Next, square matrix. Okay, square matrix both are same. Rows as well as column is the same. Then it is square matrix. Something like that. Okay. Trace is all the central element, diagonal elements, principal diagonal element. The two diagonal elements. Two diagonals. One is this diagonal. Another one is this diagonal. The principal diagonal is this. So principal diagonal element is called the trace. Fine. Sometimes it will come trace of A. What is that? Okay, so you have to understand. Determinant. You know how to find the determinant, is it not? There is one easier rule to find the determinant, which I will tell you now. Okay. So let us see the easier method. I think you know it, but still I would like to do it again so that you will not miss it out. Okay. So let us go with a new one. Okay. Uh, New blank presentation. No, sorry, duplicate. So let us, or it is over here. No, determinant. I will do one more. One second. How should I? You cannot duplicate it. No. No, I have it there only. Don't worry. I have it there. I will tell you when it comes. Okay, it is there next. Okay, I've done it. The method I've done it here. So we have to find the determinant. I hope you know that. You take the first one. You say plus, minus, plus, minus, plus, minus like that. So you take the first one, A11, and you neglect the other row column elements, other row elements, and then you write these A22 to A2n, AN2 to ANN. You have to find the determinant of that. Okay, then A12 into determinant of this, like that it goes. Okay, plus minus plus minus, like that it moves on. So any amount of things you can find out. Determinant of 2 by 2 matrix is AD minus BC, because at the end it comes 2 by 2 matrix. So if there is an n dimensional square matrix, okay, at the end it has to come to 2 by 2 matrix. Okay, non square matrices do not have determinants. It's only square matrices that have determinants. Okay, very important. Singular matrix whose determinant is 0. This is very, very important. Singular matrix is the one whose determinant is 0. Fine. Non-singular matrix, a matrix whose determinant is not 0. That's a non-singular matrix. That's right. So next, upper triangular matrix, where all the elements above are non-zero, all the elements below are non-zero, and the other elements are 0. Okay, all the elements other than the upper triangle. This is very important in CFD or finite element methods. Both places, these matrices are very important. When you code, we generally say as LU decomposition. There is one method called LU decomposition. You decompose a matrix into lower triangular and upper triangular, and that helps in solving. Okay, so let us look at that later on when we start CFD in Apex. Okay, which I have an intention, but now I'm not able to. At least 2 to 3 years I will take for that. Okay, so lower triangular and upper triangular, right? Diagonal matrix T. The diagonal will have non-zero, at least one. Even if one is there here, it's a diagonal matrix. Others should all be zero. Non-diagonal element should be 0, and at least one diagonal element should be non-zero. Then it is a diagonal element. Diagonal matrix. Scalar matrix, every element is 0 other than the diagonal. And in the diagonal, every element has the same value. Why it is called a scalar matrix? Because you multiply the scalar matrix with any other matrix, all the elements get multiplied by that number. It's like multiplication with the scalar. Every element is multiplied by the scalar. And that's why it's called scalar matrix. Now, use of matrices, this we have done that time, is to transform a vector. Okay, see, consider a vector 3, 4. Now, if you multiply by this matrix 2, 2, what is going to happen? This is called scalar matrix because it scales it up. 3, 4 becomes 6, 8. So, what is the use of a matrix? It scales it up. So it is why it's called scalar. Scalar doesn't mean just it's singular, it is scaling up. The matrix which scales is a scalar matrix. Make sense? Sure. Next. multiplication of a matrix by a scalar. Observe the difference. That time what did we do? A matrix multiplied by scalar matrix and multiplication of a matrix by a scalar. What's going to happen? If you have to say 5a, you have to multiply every element by that number. That is what is called multiplication by a scalar. Okay. Next, identity matrix. This is matrix. Keep in mind, it is not determinant. Determinant is different. Observe, determinant is different. This is a matrix. Get the difference between matrix and a determinant. Okay. It's a scalar matrix with k is equal to 1. That is called identity matrix. Identity matrix, when you multiply by that, it remains the same. It does not change. That's the identity matrix. Correct? So, now identity matrix generally should be equal to, say, multiplication should be possible. See, if you have 3 by 2 matrix, you can multiply only with the 2 by 2 matrix. So it remains the same. You understand? But generally we say identity matrix is multiplied with square matrices. Okay. Row matrix having only one row, column matrix having only one column. It's a vector actually. Column matrix. Wait a minute. Sorry, student, there is a small disconnect. What are they doing? Concept. Close it. It takes a long time then. They know when we are taking class. They come to disturb us. Close there also. A bit of opening it. Ah. Chal. Stop. It's okay. You sit here sometime. Has it gone or it is going to start again? Run. Okay, then fine. Okay. They have come just to disturb us. I don't know how Mango City Corporation knows when I'm taking classes. Mostly about they're snooping probably. Okay. So, so I hope you get that, students. Okay. Bandra innome? So this is what is row matrix and column matrix. It's generally a vector. Okay. Next, inverse of a matrix. Now, inverse of a matrix is like this. So when you multiply, say for example, a particular number by another number. Say you multiply, say 4 by 3, you get 12. Now 4 you have multiplied by 3 and made it 12. Now how to get it back to 4? So you have to divide by 3. So inverse of multiplication operation is division. Inverse of addition operation is subtraction. Right? So multiplication, now see, if A into A inverse is I, you get A into A inverse is I, then A inverse in, oh sorry, inverse of a matrix is, see, matrix generally what does it do? It changes things. It changes the nature of vector. I've told you about scalar vector. Similarly, there is rotation vector. We have seen in CFD, we have seen rotation vector, is it not? A vector is rotated by a matrix, rotation matrix. What is rotation matrix? If you remember, you can get that it is cos theta minus sin theta 1, right? Cos theta minus sin theta 1, sin theta cos theta 0, 0, 0, 1. Correct? Sorry, 0. Correct? This is counterclockwise. Ulte. So if you have a vector, you want to multiply by an angle theta, then you use this vector. this rotation vector, it rotates by that angle. So whatever point is there, that vector is there, you multiply by this matrix, what happens? It rotates. This is what is used in AutoCAD, ProE, and all those things when you code it. See, later on it is displayed. I had taught C graphics also once. I don't remember now, but still. Okay. In that we have to say pixel by pixel we have to change. Okay. So this line pixel has to change like this. So how do? You use a rotation vector. You make a for loop and you enter all the. You multiply by this for every pixels. Then the line which is there will rotate and stand there. Make sense? So that rotation which is there, you have to multiply with this particular. So we can create a rotation matrix, a rotation in C graphics. You can do it easily. Okay, which is free of cost, nothing. Okay. Now, so you have this particular thing. Now, if you want to take it back, you have taken it in like this. If you want to take it back, then you have to multiply with the inverse of that matrix. You go like this and you have to take it back. If you want to do an animation, go this way. Okay, crank and rocker mechanism. Okay, if you want to do that, it is rotating by an angle, is it not? So if you want to rotate that like that, so what do? You have to first multiply by this vector, then multiply by the inverse of this vector. What is the inverse of this vector? Inverse of this vector is cos theta sin theta 0 minus sin theta cos theta 0 0 0. That minus comes over here. That is the inverse. This is rotation anti-clockwise. Did I say it? Sorry, clockwise. First one is anti-clockwise. The second one is clockwise. So what's going to happen here? It is the inverse. Rotation anti-clockwise. Rotation clockwise is the inverse of rotation anti-clockwise. Easy. So this is what is called the inverse. Okay. Now, so A into A inverse C. For example, this is the inverse I said. So if you multiply A into A inverse, you will get minus I only, identity matrix. You can do it and see. Okay. Now, AB inverse is equal to B inverse into A inverse. This is very, very important thing you forget sometimes. AB inverse is B inverse into A inverse. Keep in mind. It's not the other way around. Okay, this has been asked a number of times. Don't forget. Okay, but okay, for a diagonal matrix, D inverse is 1 by Di of a diagonal element. These are all shortcuts, very important. So what is happening? This is a diagonal matrix. What's the inverse of this? Just reciprocate every element. So 2, 1 by 2, 5, 1 by 5. That's it. You will get a inverse. Very, very important point. Where you don't have to spend your time, you will waste time. There are ways to find inverse of a matrix. So you can use that and you can get the same answer, but your 4 or 5 minutes is lost. Don't lose that time. If you have a diagonal element, a diagonal matrix, just inverse it. Just reciprocate all the elements, you'll get it. Simple. Okay. Next. So any big thing can be done like this one. Same thing. Any big. This one, if you try to find, I'm giving you other method to find the inverse. But if you find the inverse like this, and finding the term is very difficult. So this kind of question may come in here. So they give 5 by 5 matrix and find the inverse of this matrix. It's a diagonal element. So these kind of points you have to remember. Okay. This at the end I will not be able to say always. Now I'm doing on linear algebra. But when it has been told in the class that these points you have to note down, and during the end of the during the end time or during the last few times you have to revise these things. Very important. Okay. So if you want some points, you can write. There's no problem. Okay. I think you have to learn shorthand now. Okay. When you do revision. Okay. But anyhow, that remains to be. This is there with you in the. This is there in the meet recording. The same whole thing is there. Next. Transposition and inverse of a matrix. A inverse transpose is equal to A transpose inverse. Very important. Remember this. A inverse transpose is equal to A transpose inverse. Easy? Very, very important. Fine. Next. Similarly, A inverse of inverse is equal to A. Obvious. This is simple. Okay, this proof and all those things. Inverse using an adjoint matrix. Here we have to find the minor. Minor, it's a smaller element in a this one. So from that you have to write the cofactor matrix. Now, see, minor is Mij. You have to multiply by the minor by minus 1 raised to I plus j. Then you get the cofactor. For example, you have 1, 2, 3, 4, 5, 6, 7, 8, 9 is the matrix. So here, what happens is when you have to write the cofactor matrix of this. Okay. So here you see, for 1, you have 5 into 9 is 5 nines are 40, 45. 45 minus 48, right? So 45 minus 48 is minus 3. So it will be minus 3. Have I written here? Minus 3. And then you have to write minus 1 raised to I plus j. This is 1. So this will come as minus 3 over here. Okay. So like that. Okay. So that's how we have to write the whole cofactor matrix. I will tell you the things later. Okay. ಶಾರ್ಟ್ಕಟ್ ಹೇಳ್ತೀನಪ್ಪ ಈಗ ಫಸ್ಟಿಗೆ ಆಕ್ಚುಲ್ ಆಗಿ ಹೇಳ್ತೇನೆ ಮತ್ತೆ ಯಾಕಂತ ಹೇಳಿದ್ರೆ ಕೋ ಫ್ಯಾಕ್ಟರ್ ಏನಂತ ಗೊತ್ತಿರಲಿಲ್ಲ ನಾನು ಇನ್ವರ್ಸ್ ಫೈಂಡ್ ಔಟ್ ಮಾಡಿ ಕೋ ಫ್ಯಾಕ್ಟರ್ ಏನಂತ ಫೈಂಡ್ ದ ಕೋ ಫ್ಯಾಕ್ಟರ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಅಂತ ಕೊಟ್ಟರೆ okay, adjoint of a matrix. Adjoint of the matrix is the transpose of the cofactor matrix. Whatever cofactor matrix is there, you transpose it, it's a. So let us see this. See, I'll give an example. See, find the inverse of 2, 3, 4, 4, 3, 1, 1, 2, 3. Okay, I have the actual way. The shortcut we will see later. Okay, so here what we have to do is a yeah, so what is the determinant of a? Minus 5. Determinant shortcut I will tell you in a moment. Okay, I'll write it here. Let us find the determinant shortcut. Okay, actual way is a bit difficult. See, this is the actual way of finding a determinant. You know that. Shortcut way, let's see. What you have to write? 2, 3, 4, 4, 3, 1, 1, 2, 4. Then you write 2, 4, 1, 3, 3, 2. You take this 2 into 3 into 4, 24. 3 into 1 into 1 will go like this. 3 into 1 into 1, 3. 4 into 4 into 2, 32. 4 4s are 16. 16 2s are this one. Then you go with minus. 4 into 4 into 3, 48. 4 4s are 16. 16 3s. 2 into 1 into 1, 4. Minus is that. That 4 into 3 into 1, 12. This is the shortcut to find out the determinant. Don't do the whole thing. It becomes difficult. And this you can apply for anything, any big number. Use this shortcut for finding the determinant. Any number. If it is 4 cross 4, then if there is one number here, you write 3 additional. One more. See, like if you have say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 8, 6, 3, 2, 1, 0. Suppose this is there. Then you write 2, 6, 10, 2, 3, 7, 8, 1, and 4, 8, 6, 0. Sorry, 3. What did I do? No, 1. So you write 1, 5, 9, 3, 2, 6, 10, 2, 3, 7, 8, 1. And you take this like this, like this, like this, then like this, then come back. You can find any numbers. If it is 5, leave the last one. Then everything you have to do. And the same thing you could have done if you had added this way also. This way could have been done 2, 3, 4, 4, 3, 1. This is also this. That's also this. Okay. But here the way you have to go is this way. 1, 2, 3, 4, 5, 6. But better stick. Okay, done. So this is the actual. Now adjoint, if you see, adjoint is the cofactor of Aij. Aij is the cofactor. Okay, so this adjoint transpose, cofactor transpose is there. Okay, let us see an example. First is the example. Later on, we will go with the depth. Okay, so this 2, 3, 4, 4, 3, 1, 1, 2, 4 is the matrix. So what are the minors? M11 for that is 3, 1, 4, 2. So that 3, 1, 4, 2 is the minor. What is the determinant? 10. That you write over here. How you write? You write directly, right? You 10. Here this is M12. M12, this one. 3 you mask. You have to write 4, 1, 1, 4. 4, 1, 1, 4. The magnitude of that is 15. If it is a 4 by 4 matrix, every minors will be 3 by 3. Because it is a 3 by 3 matrix, every minor is 2 by 2. Okay. So M13, what is a minor? 5, like that. You understand this one? 4, 1. Here 4, 3, 1, 2. 4, 3, 1. Fine. So like that we have found the minor matrix. Cofactor matrix is minus 1 raised to I plus j mij. So minus 1 raised to I plus j. So here for this one it will be plus, minus, plus, minus, plus, minus, plus, minus, plus. Every odd number it is a minus. Every even number it is a plus. Right? So 1 plus 1, 2. So minus 1 raised to 2 is plus only. So this remains plus 1. This becomes minus. So whatever was there becomes minus here. This is plus only, remains there. 4 has to be minus. Okay, so minus comes. This is 4 is correct. This is minus. 9 is minus. A plus, so that's why it remains same. This is minus of this, so plus. This becomes minus of that. It is plus only, so it remains. So this way. Now, adjoint of A is cofactor inverse, cofactor transpose. So you transpose that, you get adjoint. And the inverse is 1 by the determinant of A into adjoint. What was the determinant? Determinant was minus 5. So you multiply by that, and then you get the inverse. So you have to write this is, you can write minus 2. This is minus 4 by 5. This is minus 9 by 5. This is 15 by 5 minus plus 15 by 5. That is 3. Like that you have to add. But I have kept it like that. Fine. This is the inverse. So you multiply. How to check it out? You multiply A inverse with A. You should get it as identity matrix. A inverse into A should come as identity matrix. This is very, very important. Spend some time on this. Again, let me write here. So, how do you write? Matrix. I will use some other. So, what you do? Matrix. Then you find its minor. Minors together will give you, from minor you find out cofactor. From cofactor you find adjoint. From adjoint you find the inverse. Okay. Inverse is equal to adjoint of A divided by magnitude of E. Determinant of A. What is adjoint? Adjoint is minus 1 raised to I plus j into cofactor matrix, right? Cofactor matrix. Correct. What is cofactor? Sorry. Adjoint is transpose of cofactor matrix. So adjoint is cofactor matrix transpose. What is cofactor matrix? Minus 1 raised to I plus j into minor. You know what is minor matrix and what else. So this understanding, if it is there, is very important. These are maybe asked in theory questions. Can be asked. Don't forget. Right? Next. So inverse of matrix. Now, shortcut. See, this shortcut is very easy. Okay. So adjoint. So we have done the same thing. Okay. Is it the same thing? No. 1, 2, 3, 4. I think 2, 3, 4. I should have used the same thing. Okay, I will find that out. Okay. So what we have to do here is see, you are anyhow finding it. See, 1, 2, 3, 1, 3, 4, 1, 4, 3. Correct. And we have you have to write 1, 1, 1, 2, 3, 4. You can find it. Is it not? Now what you have to do is okay. Uh, just a second. Okay. So here observe. You have to find the from this you can find the determinant comes out to be -2, so we have written it. Okay, how to find out the adjoint matrix? Write this 1 2 3 1 2 1 3 4 1 3. Okay, just a minute, students. Hello, hello, who's this? Yes, which college you're from, or which when did you graduate? Yeah, one thing, tutorial for gate. We are actually a tutorial for gate. Actually, yeah, we are actually a tutorial for gate, and we give job opportunities for students generally. Okay, whoever because we have to. What is our students? We try to place them. Okay, so we contact industry and all those people. So whenever they say we have some job opportunities, I just put it on my status and all those things like that. Okay. Yeah. So see, one of the thing what is I'm in a class right now. Okay, so what you can do is don't worry, that's why I'm rushing a bit. Okay, so you can do one thing, you can send me your details on WhatsApp. This is my WhatsApp number, you can send it to this. I will respond there after my class. Okay, or I'll call you after the class. Okay, sure. My name is Dr. Ananth Pai. Thank you very much. Yes. Okay, so done. So now here, uh, once this is done, so here, what we have to do is we have to take out this one and this one. We'll take these two rows, this row and this row and this column. You take it out. Then whatever is remaining, say 3 into 4, 3 threes are 9. 9 minus, wait a minute, yeah, 16, right? 9 minus 16 is 7, right? So 9 minus 16 is -7, is it not? So you write down that -7 over here. Okay, next, again, very important. This is important, not that, just that. 4 into 1 is 4. 3 minus 3 into 1 is 3. So you get 1 more. You don't write 1 here, you write down. You are going in rows here, you come in columns over here. That is the only thing. That comes classes. So using this, within 2 minutes, you can write the inverse. It becomes easier, faster. Adjoint, minor, and all those things. No bullshit there. These are shortcuts which help you save time. Right? So then I hope you understood how it is. Correct? So this is very easy shortcut which will save time. Huh? No, this is the inverse. That's it. This is the inverse, direct inverse. First you find the determinant here. Okay, you find the determinant like this. You write 1 by -2. You found the determinant. First time what you do, you write this much, is it not? Through this you can find the determinant. Then write this down here. Then find the minor. 3 threes are 4. This you write it here. This minor you write over here. This minor you write it 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 over here. That shows transpose. So easily you can score marks. That's also possible. So you can take write as it is and then take the transpose. That's also possible. But keep in mind the transpose is important. Okay? ನೆನಪಿರ್ಬೋದಲ್ಲ Gauss elimination. ಈಗ one of the major ಏನೋ ಡೌಟ್ ಇದೆಯಾ? ಇನ್ನೊಮ್ಮೆ ಹೇಳಬೇಕಾ ಇದನ್ನ? ಸಾಕಲ್ಲ, ಕ್ಲಿಯರ್ ಆಯ್ತಲ್ಲ? ಇದು ನೀವು ಓದ್ಲಿಲ್ವಾ? ಓದಿದಿರಲ್ಲ, ನೋಡಿದಿರಲ್ಲ, ವಿಡಿಯೋ ನೋಡಿದಿರಲ್ಲ. ವಿಡಿಯೋ ನೋಡೋದು ಇಂಪಾರ್ಟೆಂಟ್ ಆಗುತ್ತೆ. ಇಲ್ಲಿ ನಾನು ಫಾಸ್ಟ್ ಆಗಿ ರಿವೈಸ್ ಮಾಡ್ತಾ ಇದ್ದೇನೆ. ಬಟ್ ಐ ಹೋಪ್ ಯು ಹ್ಯಾವ್ ಕಂಪ್ಲೀಟೆಡ್ ಲೀನಿಯರ್ ಆಲ್ಜಿಬ್ರಾ. ಇಸ್ ಇಟ್? ಡಿಫರೆನ್ಷಿಯಲ್ ಈಕ್ವೇಷನ್ಸ್ ಕಂಪ್ಲೀಟ್ ಆಗಿಲ್ಲ ಅಲ್ಲ? ಅದಷ್ಟು ಮಾಡಿದ್ದೇನೆ, ತುಂಬಾ ಲೆವೆಲಿಂಗ್ ಮಾಡಿದ್ದೇನೆ. ಇರಲಿ. System of linear equation, Gauss elimination method ಇಂದ ಹೇಗೆ ಮಾಡೋದು? Let us see that. So this is a system of linear equation. What is solution? You know, okay, a vector values of all these x's is called a solution. So that is this is called the ax vector is equal to b vector. B is a constant vector. Sorry, yeah. Augmented matrix ಅಂದ್ರೆ ಎಂತದ್ದು? Augmented matrix is, see, augmented matrix is you write the constants on one dimension, one side. That is called augmented matrix. This is the actual matrix, which is called the coefficient matrix. This is the vector whose value you have to find out, and this is the constant matrix. So coefficient matrix and the constant matrix, you combine together, you get the augmented matrix. I hope you get the point. Fine. Now, how whether the system of solutions there is existence or not, it depends on finding the determinant of that coefficient matrix. If the determinant of the coefficient matrix is 0, then there is no solutions. There are no solutions. Remember again, if the determinant of the coefficient matrix is equal to 0, there are no solution. That means these two are linearly independent. You cannot multiply, sorry, you can say no, these are parallel lines. Okay, so here x plus y and x plus y is equal to 0, x plus y is equal to 1. These means they are parallel lines. You don't have meeting at one point so that you could have. What is meant by solution? Solution means you have two lines where both the conditions are satisfied. That is meant by the solution. Is it not? Here nowhere it meets. No solution. Makes sense? Done? Okay. Now system 2. Here you see. If linearly independent. They are linearly independent. No, you don't say linearly independent. Don't talk about those things. Don't talk about that. This has no solutions. Don't talk about linear independent. That by mistake is a slip of tongue. Okay? Don't worry about that. It has no solutions. Linearly independent ಅಂತ ಹೇಳಿದ್ರೆ ನಾನು ಇದನ್ನು ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿದ್ರೆ ಒಂದು linearly independence ಆಗುತ್ತೆ ಅಷ್ಟೇ. For example, 2y plus 2x plus 2y is equal to 2, and x plus y is equal to 1. These are linearly dependent things. These are linearly independent, no doubt. But then these have no solutions. Next, this kind of things where you have the determinant being there. Okay, then this has a unique solution. Here also you get 0, but then these are linearly dependent. Sorry, here also you can see that it's 0. It has infinite number of solutions. How does it come? This system 3, you can have, it's the same thing. There's no difference. It depends on these values. Okay, so it is just a number being multiplied. Both of the cases you have 0, but what changes it? Changes are in the constants. Constant is just multiplied here. Observe. Okay, this is one. Now, let us understand much more about Gauss elimination. Gauss elimination. See, it is not just on the coefficient. It's not just on the coefficient. It's also on the. It's also on the coefficients, constants. So here you see constants are different. If you put it on the in the sense, so if you put it on the graph, you can see it. Okay. Methods I will see later. I have not come to that till now. Okay, let us see. But you have to understand this. Okay, you have to understand on the graph how it will come. This equation and this equation applied on the graph is the same. Observe. How will you write x plus y is equal to 1? How will you write 2x plus 2y is equal to 2? It's the same line, is it not? So these two lines are coinciding with each other. So it has infinite number of solutions. Here, nowhere it is coinciding. So constants are. These does not coincide with each other. No solution. Okay, this way you take. Okay, later on I will tell you more. Yes. Here they are intersecting at one point. There is a solution. Now let us see how to solve a system of two linear equations. This is what we used to do. Same thing is Gauss elimination. What do we do? Sir, if you have to do this, 2x1 minus 5x2 is equal to 2. 4x1 plus 3x2 is equal to 18. What do we do generally? We multiply, say, 2 minus 1 into 2, right? So 2 into 1 into 2, you get, see, you write here, 2 is this, okay, minus 1. So 1 into 2, that means 2 into 2, 4. So this goes to 0, correct? Then 2, 3 minus, 5 minus 3 into 2. 3 into 2 is 6, correct? So what do you get? Uh, uh-huh. Yeah, 1 into 2. I'm sorry, 1 into 2. So 5 twos are 10, 10, 2 minus 3 minus this one. So you get, so minus 7. Minus 7 x2 is equal to 14. So x2 comes as minus 2. The same thing we are going to do in Gauss elimination. Gauss elimination is the same thing. So we are going with x2. We are eliminating, right? Same things we will do in Gauss elimination. Now, if you want to solve here, what we do is, so we write 2, 5, and then 2 here. Okay, this is the augmented matrix, all right? So you have 2, 5, 2, 4, 3, 18. We write it here. Then what you do? You have to make this 0 somehow. How to make it 0? You make the this side, you say row 2 minus 2 into row 1. When you do that, what do you get here? You get 2, 5, 2, and then you get, say here, 0, then, sorry, no, wait. Yeah, wait. Just a second. Yeah, 0, correct, 0, minus 7 and 14. Make sense? Hello. Sorry, yeah. Again, bantu 7 and 14. So you write 7 x2 minus 7 x2 is equal to 14. Solve it. then go up, substitute that back, and then get the other solutions. That's what we used to do. So same thing we will do it in the three. Here four methods are there. Four rows are given. Exactly. 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 You convert it to upper triangular matrix. Here, what is happening? This is upper triangular matrix. Observe. This one is upper triangle. This is it. Eliminated. So if it is a 3 by 3 matrix, what we have to do? We have to get it as some number, 0, some number. It may be 0 also. 0, 0, some number. Then you have some coefficients. From the second row, you substitute it to the back substitution. Get the answer. This is what we do. Here you get x3. Here you get some x2 into some x3. This x3 you substitute. You get x2. Then you have x1, x2, x3. So you know x2, you know x3. Substitute here. X1 is the only unknown. You get that. That is actually Gauss elimination. Make sense? Sure. Now here, let us look at different one. Here we have 4 by 4 matrix, and here 4 by 3 matrix, and here 3 as. Okay. So we are substituting here x1 minus 1 plus 1 minus 1 plus 1 minus 1 0 10 25 20 10 6. Make sense? Now what do? We write the augmented matrix. Same thing. Okay. Now elimination of x1. So let us we have to take a pivot equation. Call the first one as the pivot equation and the coefficient of 1. So what happens? Now what we can do here, observe here. So here add 1 times the pivot equation to the second, because then it will go to 0. So what you have said, 1 times. So 1 into minus 1, 0. Minus 1, 1 plus this one, minus 1. This also goes to minus. So what will happen? All will become 0 here. Next, add 20 times the pivot equation to the fourth equation. This pivot equation 20 times we add it to it. So you get 0, 30 and minus 20. Then what you do? Eliminate x2. So what we have to do here is, one of the things what we can do is we can take it up. This you can take it down, no problem at all. So we have to take the whole augmented matrix to the upper triangle. Yes. The upper triangular matrix is this one. Yeah. Okay. Diagonal in the ಕೆಳಗಿರಲ್ಲ 0. 0. ನೋಡು ಈ diagonal ಅಲ್ಲಿ ನೋಡು ನಾನು ಹೇಳ್ತೀನಿ ಆಯ್ತಾ. ಈಗೇನಾಯ್ತು ಇಲ್ಲಿ observe here. So now we have taken it upper, this we have taken it down. Okay, then we have taken this up, which we can do always. It is just like writing one equation above the other. That's it. This we can do in lean matrices. If you do in determinant, you have to multiply by minus 1. That you have to keep in mind. If you exchange the rows or exchange the columns, you have to change the signs. Okay, so here you don't have to do that. Make sense? So here 0 0 0, you get it here. So now again add minus 3 times the pivot equation to the third equation. So when you do that, you get this as 90. So what do you have? You have this, you solve it, you get the answer. This is Gauss elimination. So you get x3 190, you can get x3. So you substitute back here 10x2 plus 25x3 is equal to 90. Spend some time. ಸರಿಯಾ? ಕ್ಲಿಯರ್ ಆಯ್ತಾ ಎಲ್ರಿಗೆ? ಫಸ್ಟ್ ಟೈಮ್ ಮಾಡೋದು ಸ್ವಲ್ಪ ಕಷ್ಟ ಆಗುತ್ತೆ ಅಂದ್ರೆ ಓಕೆ. ಫಾರ್ ದ ಪೀಪಲ್ ಹೂ ಆರ್ ರೈಟಿಂಗ್ ಗೇಟ್ ದಿಸ್ ಟೈಮ್ ಫಾರ್ ದೆಮ್ ಐ ಥಿಂಕ್ ಇಟ್ಸ್ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡಬಲ್. ಸಾಮಾನ್ಯ ಒಂದ್ಸತಿ ಮಾಡಿದ್ದೀರಲ್ಲ ಲೀನಿಯರ್ ಆಲ್ಜಿಬ್ರಾ, ತುಂಬಾ ಈಸಿ ಬರ್ತದೆ, ಮಿಸ್ ಮಾಡಬೇಡಿ. ನೀವು ಬಂದದ್ದು 1 ತಿಂಗಳು ಲೇಟ್ ಆಗ್ತದೆ, ಸೆಪ್ಟೆಂಬರ್ ಅಲ್ಲಿ ಬಂದದ್ದು ಅಂತ. ಸೀರಿಯಸ್ನೆಸ್ ಲಾಸ್ಟಿಗೆ ಮಾತ್ರ ಗೊತ್ತಾಗುತ್ತೆ, ಫಸ್ಟಿಗೆ ಗೊತ್ತಾಗಲ್ಲ, ಅದೇ ಪ್ರಾಬ್ಲಮ್ ಆಗಿ. ಏನಾದ್ರು ಬಿಟ್ಟು ಸರಿಯಾ? ಆದ್ರೆ ಬಿಡಬೇಡಿ ಅಷ್ಟೇ. ಈಗ ನೀವು ಜಾಬಿಗೆ ಹೋದ್ರೂ ಪರವಾಗಿಲ್ಲ, ಹೋಗ್ಲೇಬೇಕಂತ ಹೇಳೋದಿಲ್ಲ ನಾನು ನಿಮ್ಗೆ. ಜಾಬಿಗೆ ಹೋದ್ರೆ ಕೂಡ ನೀವು ಇದನ್ನು ಬಿಡಬಾರ್ದು ಅಷ್ಟೇ. ನೆಕ್ಸ್ಟ್ ಎಲಿಮೆಂಟರಿ ರೋ ಆಪರೇಷನ್ಸ್ ಎಲ್ಲ ನೋಡಿದ್ದೇವೆ, ಡೋಂಟ್ ಹ್ಯಾವ್ ಟು ವರಿ. ಓಕೆ, ರೋ ಈಕ್ವಲೆಂಟ್ ಆಫ್ ಸೇಮ್ ಸೆಟ್ ಆಫ್ ಸೊಲ್ಯೂಷನ್, ದಟ್ಸ್ ಕರೆಕ್ಟ್. ಓಕೆ, ಈಗ ಇದನ್ನು ಸಾಲ್ವ್ ಮಾಡುವ ಇನ್ನೊಂದು ಮೆಥಡ್ ಇದು ಕೊಟ್ಟಿದ್ದೇನೆ, ಇನ್ನೊಂದು ಎಕ್ಸಾಂಪಲ್ ಆಯ್ತಾ. ವಿ ಹ್ಯಾವ್ ಸಾಲ್ವ್ಡ್ ಇಟ್. ಓಕೆ, there are three things where it became, see when you solve this, solution was there. Okay, this solution you see here, after a bit of time we cannot find the solutions. There are more number of unknowns, there are less number of knowns, less number of what is it? You cannot find it out at all. You can say this by rank. Next slide, just to see now, okay, how the things goes. ಅದು ರ್ಯಾಂಕ್ ಇದೆ, ನೆಕ್ಸ್ಟ್ ಬರ್ತೀನಿ. ಏನ್ ಮಾಡ್ತೀನಿ ನಾನು ಅಂದ್ರೆ ಪ್ರಿಪೇರ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ ನಿಮ್ಗೆ ಅಷ್ಟೇ. ಸೊ ಈ ಸರ್ತಿ ಲೀನಿಯರ್ ಆಲ್ಜಿಬ್ರಾ ನ್ಯೂಮರಿಕಲ್ ಮೆಥಡ್ಸ್ ಇದೆಲ್ಲ ತುಂಬಾ ಚೆನ್ನಾಗಿ ಮಾಡಿದ್ದೇನೆ ನಾನು. ಇದು ಮಾಡಿದ ಹಾಚ್ ಪಾಚ್ ಮಾಡಿ ಇಲ್ಲ, ಕಾಂಪ್ಲೆಕ್ಸ್ ನಂಬರ್ಸ್ ಕರೆಕ್ಟ್ ಆಗಿ ಮಾಡಿದ್ದೇನೆ. ಸ್ವಲ್ಪ ನಮ್ಮ ಲಾಸ್ಟಿಗೆ ಮ್ಯಾನ್ಯುಫ್ಯಾಕ್ಚರಿಂಗ್ ಸ್ವಲ್ಪ ಫಾರ್ಮಿಂಗ್ ಅಲ್ಲಿ ಮಾತ್ರ ಸ್ವಲ್ಪ ನಂಗೆ ಸರಿಯಾಗಿಲ್ಲ, ಮತ್ತೆ ಬಾಕಿ ಎಲ್ಲ ಸರಿಯಾಗಿದೆ. ಕಾಸ್ಟಿಂಗ್ ಆಗಿದೆ, ಕಾಸ್ಟಿಂಗ್ ಒಳ್ಳೇದು ಮಾಡಿದ್ದೇವೆ, ವೆಲ್ಡಿಂಗ್ ಮಾಡಿದ್ದೇವೆ, ನಮ್ಮ ಇದು ಯಾವುದು ಯಾವುದಿದೆ ಮೆಷಿನಿಂಗ್ ತುಂಬಾ ಟಾಪ್ ಆಗಿ ಮಾಡಿದ್ದೇವೆ ನಾವು. ಮೆಷಿನಿಂಗ್ ಅಲ್ಲಿ ಏನೂ ಇದಿಲ್ಲ, ಇಂಡಸ್ಟ್ರಿಯಲ್ ಚೆನ್ನಾಗಿ ಮಾಡಿದ್ದೇವೆ ಆಯ್ತಾ. ಮಿಸ್ ಆಗಿದ್ದು ಫಾರ್ಮಿಂಗ್ ಅಲ್ಲಿ, ಈ ಸರ್ತಿ ಅದನ್ನು ಇಂಪ್ರೂವ್ ಮಾಡೋದು ಆಯ್ತಾ. ಎಲ್ಲ ಹೇಳ್ಕೊಟ್ಟಿದ್ದೇನೆ, ಆದ್ರೆ ಏನಾಯ್ತು ಅಂತ ಹೇಳಿದ್ರೆ ಚಂದ ಆಗಲಿಲ್ಲ ಅಷ್ಟೇ. ವಿಷಯ ಹೇಳೋದಲ್ಲಿ ಹೇಳ್ಕೊಟ್ಟಿದ್ದೀನಿ, ಚಂದ ಆಗಲಿಲ್ಲ. ಸೊ ದಟ್ ಐ ಹ್ಯಾವ್ ನೋ ದಿಸ್ ಟೈಮ್, ಸೊ ನೆಕ್ಸ್ಟ್ ಟೈಮ್ ಐ ಇಂಪ್ರೂವ್ ಆನ್ ದಟ್. ಓಕೆ, sure. So augmented matrix stuff. Okay, so now what is happening here? You cannot get into upper triangular matrix. Whatever you do, tipper laga hakidru hakidru ಆಯ್ತಾ. So it has infinitely many solutions. ಸರಿಯಾ? Next, echelon form ಅಂತ ಇದೆ, echelon. Okay, echelon form ಅಲ್ಲಿ ಏನು? This is the echelon form. So you have to try it to get into the echelon form. Okay, so echelon form is the final thing what you do. See here, echelon form, understand this. Echelon form may not have this only one number being there. There might be more than one. So this is the echelon form. So you have R here, observe the R here. This is BR until the echelon form. What is the R's you have? Other B's also you have. Okay, so we have reduced it to echelon form. Okay, like this, and there are B's here. No, don't have to worry about the B's. Okay, this is the row echelon. Now here, if R is less than M, what is M? M is the number of equations. M is the number of equations. So if R is less than M, one of the numbers is non-zero, then the system has no solutions. That means BR plus 1, wait a minute, BR plus 1 to BM. One of the numbers from BR plus 1, this is not N, this is R. R plus 1 to BM is non-zero. Here, at least one thing is there which is non-zero, then it has no solutions. Wait again. System has no solution if R is less than M. That is, number of equations are more, the number of constants are more than the number of row echelon form equations. When you get into the row echelon form, number of the R here is less than M. Not upper triangular matrix. See, upper triangular matrix is also echelon form. Say some of the lower triangle of that becomes 0. Even then it's echelon form. Observe here, this is echelon form. Is it upper triangular matrix? No. You may have another 0 here. You can put another 0. This is not an echelon form. Sorry, this is echelon form. This is not an upper triangular matrix. Is this upper triangular matrix? No. But it's an echelon form, row echelon form. See, row echelon form, how it is. Here we have some numbers. Spend some time on this. So here after this, see, m number of equations should be more. M is more than the R is less than M. That is, M is more than R. And one of the B's from R is equal to 1 into M is non-zero. Then it has no solutions. Next, precisely one solution. If R is equal to N and BR plus 1 is 0 if present, all the other things are 0, then it has precisely one solution. Infinitely many solution if R is less than N, not M here, and also BR plus 1 to BM is 0. So what is happening? R is less than N means what? N is this number of unknowns. That means number of unknowns is more than number of equations. That you can tell it now. You don't need me to tell this. If number of equations are less than number of unknowns, or number of unknowns is more than number of equations, then infinitely many solutions. That you will tell it now. Sir, I have 3 equations, I have 5 unknowns. Can I get a solution at any point of time? No, that you can tell it once. Which one? They are constants. R plus 1, n not n plus 1, R plus 1. Let me check. Number of non-zero. R is here, no? This is R. Here in this case, what is R here? 2. In this, R is 2. Sorry, R is 2 here. So R is 2. Whereas here also R is 2. In this case, R is 3. Not rank. It comes to rank 1. Rank 1. Non-zero rows. Yes. Non-zero rows. Let us look at it in terms of ranks. Okay. Let us look at it. Linear independence, dependence, and all those things is there. So let us not worry about that much. Rank of a matrix. If the maximum number of linearly independent rows of the matrix is called the rank matrix. So that R actually comes out to rank of it. Okay. So let us see this. So now there are a number of things which are there here. We'll not worry about that. Okay. Now basis we have seen. We will skip this up. Okay. Evaluation of rank, very important. I think you know what is rank means. Rank means the minimum. See, for example, here you have to see rank of we have to find the determinant of this. Okay, so determinant is 0. So rank of A is less than 3. Then you take all the minors of that. That this I'm telling you the understanding of what is rank. Okay, now this one will go to 0. What is rank here? Let us see the definition of rank. Rank of a matrix equals maximum number of linearly independent column vectors. Or also it means that what is the minimum number or minimum size of non-zero square determinant. Okay, non-zero square determinant, that is the rank. For example, see, yeah, for example, here let me finish. So here we are going to score a high mark. So we are not worried about all the theory now. We are worried about getting the marks. That's it. Okay. So here 4284. Is it not? So now, sorry. Now this particular one. What is the determinant? 0. So rank is not 3. Fine. Next you take every minor 42840, 23460, 8 4 minus 2 minus 1, 8 4 minus 2 minus 1 0, 4 6 minus 1 minus 1.5, that is 0. Then here next 4 minus 2 2, 4 minus 2, you take 3 minus 1.5, that is 0. This is also 0. So all the 2 by 2 matrix is also 0. So then the rank is 1. This is the basic thing. Okay. So observe here. In this also, observe here. When sometimes what you can do is you can do row operations and make something to 0. Some rows and columns you can make it 0. So what is a non-zero row? Only 1. So rank is 1. Here whatever you do, you cannot reduce it. So rank is 3. Okay. Similar way here for this the rank is 2. So more and more practice you do, only then you'll get it. You can't do it otherwise. Here you see, here also, okay, rank is 1 for this. Okay, so we can see that. Okay, why did I write rank 4? For this whole thing. Okay, no doubt. For this rank is 2. When you do that, you can see now existence solution of linear system. This is another one based on rank. That time we had seen on row echelon form. Here we are seeing in terms of rank. Okay, see here a linear system of m equations and unknowns is given. N unknowns are given. Has solution if and only if the coefficient matrix A and the augmented matrix A have the same rank. It is similar to finding the row echelon form. So if the augmented matrix and the row echelon matrix, sorry, the coefficient matrix both have the same rank, then what happens? It has solutions. Make sense? I'm not saying it is unique solution or not. It has solutions. Right? Next, uniqueness. System 1 has precisely one solution if and only if common rank R of A and A trans A augmented equals number of variables. The rank has to be same and number of equations has to be equal to number of unknowns. That's it. I'll repeat again. Rank of the matrix and rank of the augmented matrix. This is the coefficient matrix. This is the augmented matrix. Coefficient matrix and augmented matrix should have the same rank. And number of equations should be equal to number of solutions. Sorry, number of equations should be equal to the number of unknowns. Then unique solution. If the number of unknowns is more than the number of unknowns is more than the number of equations, infinitely many solutions, which is common sense. Getting it? No? I'll repeat again. Okay, give it 2 minutes. Okay, I'll repeat again. See, there is augmented matrix. Sorry, there is coefficient matrix. There is augmented matrix. Augmented matrix means you have only the coefficient rank. Rank of this is equal to rank of this. Solution exists. Solution exists. Solution exists. Now, if the rank of the augmented matrix, which is equal to the rank of the coefficient matrix, is equal to the number of unknowns, but again, Rank of the coefficient matrix, rank of the augmented matrix is the same. I'll write it here so that otherwise you will not. So a rank of the A matrix is equal to rank of the A augmented matrix, then solution exists. This is equal to the number of n's. Exactly. If x1, x2, x3, 3 and both rank is also 3, then unique solutions. If n is more than this rank, then infinitely many solutions. Is more than the rank of augmented matrix. Yes. N is more than, so if I say this is less than n, so this is unique solution. If rank of A is equal to rank of A, rank of A is equal to rank of A transpose or A augmented is less than n, then infinitely many solutions. No solution is not equal. Not rank only not equal, then no solutions. Then it is one solution. Infinite. So here see R of A, I'll repeat again, R of A is equal to R of A tilde. Two things are there. Two things are there. Okay. This is less than n and equal to n. Equal to n unique solution. Less than n infinitely many solutions. ಇದನ್ನು ಅಚ್ಚಾಕೊಳ್ಳಿ ತುಂಬಾ ಇಂಪಾರ್ಟೆಂಟ್ ಇದು ಎಷ್ಟೋ ಸತಿ ಮುಂದೆ ಇನ್ನೊಂದು ಐಗನ್ ವ್ಯಾಲ್ಯೂಸ್ ಇದೆರಡು ಇಂಪಾರ್ಟೆಂಟ್ ಸರಿಯಾ ಅಷ್ಟು ತಲೆಗೆ ಆಯ್ತು ಮುಂದೆ ಹೋಗುವ ಸರಿ ಎಲ್ಲ ಈಕ್ವೇಷನ್ಸ್ ಎಲ್ಲ ಎಷ್ಟೋ ಮಾಡಿದ್ದೇನೆ ಈ ಸರ್ತಿ ತುಂಬಾ ಕ್ವಶನ್ಸ್ ಮಾಡಿದ್ದೇನೆ ಸೊ ಐ ಆಮ್ ಹ್ಯಾಪಿ ವಿತ್ ದಟ್ just look at the equation solutions and I have done from old question papers also eigenvalues eigenvectors ready ya ನಾನು ರೆಡಿ ಇಲ್ಲ ಒಂದೇ ಒಂದು ನಿಮಿಷ ನಾನು ಸ್ವಲ್ಪ ಟಾನಿಕ್ ತಗೊಳ್ತೀನಿ ಟಾನಿಕ್ ಇಸ್ ಹಾಟ್ ವಾಟರ್ what tonic gin and tonic today's class was very productive is it not please improve your this is what revision should be this is because we did it well from tomorrow also we'll do the same way I've been getting correct answers for this but still that one small doubt is there I'm sorry but Ajay did not come I think he would have come okay yeah so anyhow chalo eigenvalues and eigenvectors oh. This is NaCl salt huh? No, it's not sustainable. What is it here? No, no. Bottle is different. It's Kantamrut. Okay. Chalo. So, eigenvalues and eigenvectors. Okay. What is eigenvalues and eigenvectors? I have told a lot about this. Okay. So, one of the things is that, see, when you multiply a matrix by a vector, you multiply a matrix by a vector. If it happens such that it is equal to multiplying a scalar with the vector. scalar with a vector. Then this x bar is the eigenvector of this matrix A. That is, if you multiply the eigenvector of a matrix A by, if you multiply eigenvector of matrix A to the matrix A, or matrix A to the eigenvalues of the eigenvector of the matrix A, then you get eigenvalues into that vector. So A can be any number. So A matrix you have, this is matrix A, then you have an eigenvector, matrix A into eigenvector is equal to the eigenvalue into the eigenvector. ತುಂಬಾ ಏನು ಹೇಳ್ತಾರೆ, very important and not understood thing much. Now why this is there? This is what is principal stresses our uh, in our uh, in the uh, in strength of materials. You have principal stresses and principal strains. So this eigenvector corresponds to the principal axis. So if you put a three-dimensional thing, this eigenvector corresponds to principal axis, okay, or the principal direction. This is also used in moment of inertia, okay, which has the maximum moment of inertia, along which line you have maximum moment of inertia. Then also you have to find the eigenvalue. Very important. CFD, in FEM, in control systems, in communications, wherever you go, these eigenvectors and eigenvalues are very important. That's why it is there in almost every engineering streams. You tell me one engineering stream of gate which does not have eigenvalues and eigenvectors. Everything has, including computer science. Okay, why? That's so important. Okay, let us see that. Now, there has been a lot of things. This will not worry about it later on. Let us see. See, for example, a matrix minus 5 to 2 into, this is a matrix, right? You multiply by x1 x2, you should get a lambda into x1 and x2. That's the main thing. So we don't know what is lambda, we don't know what is x1 and x2. So what do? You write minus 5 to, you write lambda into x1, right? Minus 5 into x1 plus 2 into x2 should be equal to lambda into x1. 2 into x1 minus 2 into x2 should be lambda into x2. Now what I can do is I can negate from everything. I will say, let me take this to the other side. If I take it to the other side, what I'll get, plus this minus lambda. So 5 plus lambda into x1 is equal to x2. This should take it to 2x1 minus 2 into 2 plus lambda into x2 is equal to 0. What is this equivalent? This is equivalent to this characteristic equation, which is a minus lambda I is equal to x1. Getting this? So solution of this gives you what? The value of lambda. Make sense? Clear? ಎರಡು ನಿಮಿಷ ತಗೊಳ್ಳಿ ಹೇಗೆ ಮಾಡಿದ್ದೀನಿ. ಇದು, this is the theory. This is the theory. I'll apply this. ಒಂದು ಎಕ್ಸಾಂಪಲ್ ತಗೊಂಡು ಆ ಥಿಯರಿನ ಅಪ್ಲೈ ಮಾಡಿ ಅಷ್ಟೇ. ಅರ್ಥ ಆಗಿದೆಯಾ? ಇದನ್ನು ಜಸ್ಟ್ ಈ ಕಡೆ ತಗೊಂಡು ಬಂದ ಅಷ್ಟೇ, ಏನು ದೊಡ್ಡ ವಿಷಯ ಮಾಡಲಿಲ್ಲ. ಸಾಮಾನ್ಯ ಅರ್ಥ ಆಯ್ತಾ? ಸರಿ, ಯಾರಾದ್ರೂ ಬಂದ್ರೆ ಇಲ್ಲಿ ನಿಹಾಲೆ ಬಂದ. ಸೊ ಐಗನ್ ವ್ಯಾಲ್ಯೂ ಈ ತರ, ಸರಿಯಾ? ನೆಕ್ಸ್ಟ್, ಈಗ this equation, so homogeneous equation has solution only when determinant of this is equal to 0. So you find this determinant should be equal to 0. So we found the determinant and it is called the characteristic polynomial. So you have to get the determinant of that and you get the characteristic polynomial. This characteristic polynomial, when you solve, you get the eigen values for the vector. So corresponding to every eigenvalue, there is eigenvector. It's not one. If it is a 2 by 2 matrix, there are 2 eigenvectors, 2 eigenvalues. Corresponding to each eigenvalue, there is eigenvector. Make sense? So here, corresponding to lambda 1 is equal to minus 1, lambda 2 is equal to minus 6. Here. Corresponding to lambda 1 is equal to minus 1, you have to put into this equation. Should be equal to 0. You solve this, you get eigenvector. You have to find x1 and x2. Corresponding to lambda 1 is equal to minus 1. Wherever lambda is there, you put minus 1. So you get it, is it not? So when you use that, you get the eigenvector. So corresponding to minus 1, you have this eigenvector. Corresponding to another one, which is minus 6, you will have another eigenvector. Corresponding to minus 6, you have another eigenvector. And you will see that these two are perpendicular to each other. Perpendicular to each other in 2 by 2 matrix. Huh? Because it is like you can look at it, you can plot it, okay. But generally, what happens? See, when you pull a sheet on one direction, other direction compresses. So the first one is this eigenvector, second one would be this one. Those are eigenvalues and eigenvectors. Very important. Very important later on also. That yes. I'll do the third. See, I am telling you the what is eigenvalues. Shortcuts will do it. This is the method. Exactly. This is the method. This has no exceptions. You cannot say shortcuts when I say, okay, if this is the case, you can apply this. Otherwise, you should not. Method is this. This is the method to find out the eigenvalue and eigenvector. If nothing ಹೋಳಿಲಿಲ್ಲ ಆದರೆ ಇದು ಮಾಡಿ ಸ್ವಲ್ಪ ಟೈಮ್ ಜಾಸ್ತಿ ತತ್ತ ಆನ್ಸರ್ ಅಂತ ಸಿಗುತ್ತೆ ನಿಮಗೆ ಶಾರ್ಟ್ಕಟ್ ಹೊಳಿದ್ರೆ ಮಾಡಿ ಆ ಟೈಮಲ್ಲಿ ಒಮ್ಮೊಮ್ಮೆ ಪ್ರೆಷರ್ ಹೊಳೆಯೋದಿಲ್ಲ ಆಗ ಏನು ಮಾಡಿ ತಪ್ಪು ಮಾಡಬೇಕು ಹೊಳಿದ್ರೆ ಫ್ಯಾಂಟಾಸ್ಟಿಕ್ ಸರಿಯಾ now these all the things we will not worry about it. Okay. Applications ಮಾಡಿ ಹೋದೆ ನಾನು this was that time we did, now again I'll not do it. Okay, don't worry. Okay. Eigenvalues from Markov process I tried to do, it took a lot of time. Next, Cayley Hamilton theorem, ಇದು eigenvalues ಅಲ್ಲಿ ಇಂಪಾರ್ಟೆಂಟ್ ಆಗುತ್ತೆ ಆಯ್ತಾ. ಸೊ ಏನಾಗುತ್ತೆ Cayley Hamilton theorem says that every square matrix satisfies its characteristic equation. Or let them spend time. No urgency. So we had done this in June. Very nicely we had done it. What is Cayley Hamilton theorem? Every square matrix satisfies its characteristic. What is characteristic equation? When you put the eigenvalue and you make it 0. This is the characteristic equation. So if you consider this matrix, instead of you write lambda here. Okay, what happens? Instead of lambda, you put a, the value of a only. A is the determinant of a. Or sorry, not determinant, the matrix only. You put matrix a square. You can see. For example, here one equation is there. A minus lambda is, when you do the characteristic, is lambda square minus 5 is equal to 0. And when you put it lambda square, you see it is 5 times I. So here, see, this is equal to square. A square is this. So a square minus lambda square I is equal to 0. That is the characteristic equation. Lambda square minus 5 is equal. Similar way, another example we have taken. Okay, so just a second. And also there's one more point. If you get the eigenvalue, very important. If you find the eigenvalue using characteristic equation, you can find the inverse also. See, observe here. If you multiply both sides by A inverse, you get this. So you can get A inverse directly. A into A inverse is what? What is A into A inverse? I. So using that, you can find easily the inverse also. Okay. That I will leave it to that. To it. See, there is an equation. Find A power 8. A square is equal to 5I. How did I get that? For this particular equation. For this particular matrix only, not for other matrix. Every matrix characteristic equation is different. So you have to find the characteristic equation, and using that you can find what is A power 8. So these kind of questions will come in gate. They'll give an equation and say A power 25. You have to put A minus lambda I. So you have to do some algebraic manipulation and you get. Just see this afterwards. It will take some time. Okay, write the Cayley-Hamilton theorem. From this you have to write. Okay, it takes. I'll not waste time here. It's easy. You will get. The question was there. Very good. If you determinant B and B is equal to A square plus 5I plus 5A plus 2, and there's determinant of B. So this starts to A square. So this way you can find the inverse very easily. Okay, and sometimes without this you cannot do it. Inverse how to find it? See, this is the characteristic equation. Okay, A square minus lambda I. How did it come? It came from here only. I cannot use any other thing. What here? So it is a lambda square minus 5. This is the characteristic equation. Instead of 5, you put 5I. So lambda square minus 5I is equal to 0, or A square minus lambda square into I is equal to 0. What is lambda? Lambda has come as plus or minus 5, root 5, right? So lambda square is 5 only. This is the characteristic equation. This characteristic equation I have used here. So ಆಯ್ತಾ ಆಯ್ತೇನ್ರಿ ಆಗಲಿಲ್ಲ ಸರಿ ಆಗಿ ಕ್ಲಿಯರಾ ನೆಕ್ಸ್ಟ್ ಸೊ ಹಾಗೆ ಎಷ್ಟೋ ಮಾಡ್ಬೋದು ಎಷ್ಟೋ ಕ್ವಶನ್ಸ್ ಇದೆ ಗೇಟಲ್ಲಿ ನೀವು ಓಲ್ಡ್ ಇದು ನೋಡಿದ್ರೆ ಗೊತ್ತಾಗ್ತದೆ ಎಷ್ಟೋ ಕ್ವಶನ್ಸ್ ಇದೆ ಇದರಲ್ಲಿ ಆದರೆ ಎಲ್ಲ ಮೆಕ್ಯಾನಿಕಲ್ ಅಲ್ಲಿ ಬರೋದಿಲ್ಲ ಬಾಕಿದ್ರಲ್ಲಿ ಬರ್ತದೆ ಆಯ್ತಾ ಸೊ ನಮ್ಮಲ್ಲಿ ಒಂದು there is one Wiley book which has all the things. I have it here. So all the old mathematics questions from all the exams, all the streams has come together. So that you can use. Okay. Next, see, using Cayley-Hamilton to find A inverse. Okay, this is university exam, but still you can use it. Okay. So what happens? What is the characteristic equation? This is the characteristic. Fine. So using that characteristic equation, we have applied this here. So here you can find that it is same. I just saved that. Okay. I've repeated every square, every matrix satisfy characteristic equation is this. Fine. Now this one here, observe. Now you have to multiply by A inverse once. When you multiply by A inverse, you get this. Observe. Wait. So A cube minus 11A square minus 4A minus I. This is the characteristic equation. Now multiply this whole thing by A inverse. So you get A square plus 11A minus 11A plus 4I, because A into A inverse is I, and you get A inverse. You take this the other way around. A inverse. A inverse is minus A square plus 11A plus 4I. You put that, you get the A inverse right. Spend some time. Hello, Vaidya. Confidence banta. So ಹಾಗೆ ಎಲ್ಲ ಮಾಡ್ಬೋದು. So then we have sent using the other method we have done that. Similar way, see. Find A power 4 for the same thing. What you have to do? A cube is there, multiply by A. So A cube we can get by this. Then multiplying both sides, you get A4. Then you apply A cube. This becomes a bit long, but there are places where it becomes easier also. Such kind of things only comes in. Now, important properties of eigenvalues. These properties is what is called shortcuts. Okay. What is shortcuts? Properties. Using properties, you find the eigenvalues. That is shortcuts. Okay. The trace of the matrix is equal to the sum of the eigenvalues. Trace of the matrix is equal to the sum of the eigenvalues. That is lambda 1 plus lambda 2 plus lambda 3, which is equal to 1 plus 1 plus 2, 1 plus 1 plus 2. We are not saying, very important to understand, we are not saying lambda 1 is equal to 1, lambda 2 is equal to 1, lambda 2 is equal, lambda 3 is equal to 2. No. Lambda 1 plus lambda 2 plus lambda 3 is equal to 1 plus 1 plus 2 is equal to 4. Does not mean lambda 1 is equal to 1, lambda 2 is equal to 1, and lambda 3 is equal to 2. Don't take that. Don't take trace is equal to the this one. No. Sum is equal. Trace is equal to the sum of the principal diagonal element. What is trace? Trace is, I just said. For example, here in this, we have got lambda 1, lambda 2 is equal to plus or minus root 5. Now, if you add both, what will happen? You get 0. You add these two, you get 0. Make sense? This is what we have done already. That's what we checked. Product of the eigenvalues is equal to the determinant. So you multiply the eigenvalues. We have got lambda 1, lambda 2 is equal to plus or minus 5. So product lambda 1 into lambda 2 is this, right? What is that equal to? Is equal to the determinant of the. These two are equal. Product is equal to the determinant. Sum is equal. Sum of the trace is equal to the sum of the eigenvalues. Both are equal. So like that in GATE, there are a lot of questions which has come directly. You just look at this, for example, for matrix, the eigenvalues are. You don't have to do the whole thing. You make addition here. 4 plus 4, 8. See where it comes to 8. 3 and 5 are the only thing where it comes to 8. Done. 1 minute, you get the answer. Don't have to do a lot of things. This is what we call a challenge. You are using the properties. The sum of eigenvalues of the matrix is, they have given the matrix and they've asked the sum of the eigenvalues. If ನಿಮಗೆ ಈ ಪ್ರಾಪರ್ಟಿ ಬರಲಿಲ್ಲ ಆದರೆ ಇದೆಲ್ಲದ eigenvalue find out ಮಾಡಿ ಮತ್ತೆ sum ಮಾಡಿ ಆನ್ಸರ್ ಆಗುತ್ತೆ. But you know the property that sum of the trace is equal to the sum of the eigenvalues. So 1 plus 5 plus 1 ಮಾಡಿ ಅದೇ ಆನ್ಸರ್. ಇದು ಗೇಟ್ ಅಲ್ಲಿ ಬಂದಿದೆ 2004 ಒಂದು ಮಾರ್ಕಿಗೆ. ಇದು 2003 ಬಂದಿದೆ. ಇನ್ನೂ ಬಂದಿದೆ ನೋಡಿ 2004 ಇದೇ ಸೇಮ್. The eigenvalues of the matrix are sum ನೋಡಿ 4 plus 1 ಎಲ್ಲಿ 4 plus 1 ಬರುತ್ತೆ ಅಂತ ನೋಡಿ. ಸರಿಯಾ? ಭರತ್ಗೆ ಏನಾಯ್ತು ಹೇಳಿ ಭರತ್. ಮೈಕ್ ಇಲ್ವಾ? ಸರಿ ಸರಿ ಸರಿ. ಈ ಸರಿ ಉಂಟಲ್ಲ, ನಿಮ್ಮ ಮೈಕ್ ಆನ್ ಮಾಡಿದ್ದೀರೇನ್ರಿ ಭರತ್? ಸ್ವಿಚ್ ಆನ್ ದ ಮೈಕ್ ಅಂಡ್ ಸ್ಪೀಕ್. ಸುಜಿತ್ ಕೇಳಿಸ್ತಾ ಇದೆಯಾ? ಮಾತಾಡಪ್ಪ ಏನಾದ್ರು. ಹಾ ಭರತ್, ನಿಮ್ದು ಪ್ರಾಬ್ಲಮ್ ಕರೆಕ್ಟ್ ಮಾಡಿ. ಏನಾದ್ರು ಡೌಟ್ ಇದ್ರೆ ಈಗಲೇ ಕಾಲ್ ಮಾಡಿ ಕೇಳಿ. If your mic is giving trouble, call me now. ಸುಲಭನಾ? ಇದೆಲ್ಲ ನೋಡುವಾಗ ಗೇಟ್ ಪಾಸ್ ಮಾಡ್ಬೋದು ಅಂತ ಅನ್ಸುತ್ತೆ. ಅದು ಈಗ ಸ್ವಲ್ಪ ಇದ್ರ ಮಾತ್ರ ಇರೋದು 10-15 ಮಾರ್ಕ್ಸ್ ಮಾತ್ರ ಹೀಗೆ. ಅದು ಬಂದ್ರೆ ಬಂತು, ಬರದೇ ಇದ್ರೆ ಇಲ್ಲ. ಸೊ ಎಲ್ಲ ಗೇಟ್ ಅಲ್ಲಿ ಒಂದು 10 ಮಾರ್ಕ್ ಈ ತರದ್ದು ಇದ್ದೇ ಇರ್ತದೆ. ಸೊ ಅದು ಕಂಡುಹಿಡಿಬೇಕು ಅಷ್ಟೇ. ಆದ್ರೆ ಇದು ಈಸಿ. ಇದು ಯಾರಿಗೆ ಹೇಳೋದು? ಯಾರಿಗೆ ಗೇಟ್ ಪಾಸ್ ಆಗ್ಲಿ ಕಾನ್ಫಿಡೆನ್ಸ್ ಇಲ್ವೋ ಅವರಿಗೆ ಇದೆಲ್ಲ ತೋರಿಸಿ ಖುಷಿ ಆಗುತ್ತೆ. ಬಟ್ ರಿಯಾಲಿಟಿ ಏನು ನಿಮ್ಗೆ ಗೊತ್ತಿದೆ. ರಿಯಾಲಿಟಿ ಅಷ್ಟೊಂದು ಸುಲಭ ಇದೆ. ಸರಿ, just like a person who is not ready to marry, you show him a beautiful girl, he'll feel like marrying. Okay, then you don't tell all the details. Yes, yes please. Tell me
examples eigenvalues ಮತ್ತೆ eigen vectors ಇದೆ. eigenvalue ಮತ್ತೆ eigen vectors
ಎಕ್ಸಾಂಪಲ್ಸ್ ಬರುತ್ತೆ ಮುಂದೆ, ಆಯ್ತಾ? ಆಯ್ತಾ, ಇನ್ನು ಪ್ರಾಬ್ಲಮ್ಸ್ ಮಾಡೋಕೆ ಬರುತ್ತೆ, ಆಯ್ತಾ? ನಾನು ಹೇಳ್ತೇನೆ. ಸೊ ಒಂದು ಎಕ್ಸಾಂಪಲ್ ಮಾಡಿದ್ದೇವೆ ಆಲ್ರೆಡಿ ಅಲ್ವಾ? ಇಲ್ಲಿ ಮಾಡಿದ್ದೇವೆ ನಾವು ಐಗನ್ ವ್ಯಾಲ್ಯೂ ಮತ್ತು ಐಗನ್ ವೆಕ್ಟರಿಗೆ ಅಲ್ವಾ? ನೋಡಿ, ಅಬ್ಸರ್ವ್ ಮಾಡಿ ಇಲ್ಲಿ. ನೋಡಿ, ಇದು ಮ್ಯಾಟ್ರಿಕ್ಸ್. ಇದು 2 ಐಗನ್ ವ್ಯಾಲ್ಯೂ ಬಂತು ನಮಗೆ. ಯಾವುದು? -1, -6. Corresponding to -1, we got the eigen vector as 1 and 2. Corresponding to -6, we got 2 and -1. This is the example. One example we have taken. Other example we will get. ಅಪ್ಲಿಕೇಶನ್ಸ್ ಕೇಳಬೇಡಿ, ಈಗ ಸ್ವಲ್ಪ ಕಷ್ಟ ಆಗುತ್ತೆ ಈಗ ಮಾಡ್ಲಿಕ್ಕೆ, ಆಯ್ತಾ? ನೋಡಿ ಇನ್ನೊಂದು. So 2004 only. Okay. See, for the matrix A, observe this. This is from one of the textbooks. For the matrix A, one of the eigenvalue is, no, it's not from the textbook, -2. The eigenvector corresponding to this eigenvalue is, ಬಂತಲ್ಲ ಅವ್ನು ಕೇಳಿದ ಐಗನ್ ವೆಕ್ಟರ್ ಎಕ್ಸಾಂಪಲ್ ಬಂತು. ಏನ್ ಮಾಡ್ಬೇಕು ಅದರಲ್ಲಿ? ಯು ಹ್ಯಾವ್ ಟು ರೈಟ್ 3 - 2, 3 - -2, 2 0 2 -2, and 3 1 -2. So you get the vector. Using that you can find the eigen vector. 5 ಇದನ್ನು ಸಾಲ್ವ್ ಮಾಡಬೇಕು, ಈ ಈಕ್ವೇಷನ್ ಸಾಲ್ವ್ ಮಾಡಬೇಕು ಅಷ್ಟೇ. ಡೈರೆಕ್ಟ್ ಆಗಿ x1 x2 x3 ವ್ಯಾಲ್ಯೂ ಬಂತು. ಸುಲಭತೆ ಕೊಡ್ತಾರೆ, ಅಷ್ಟೊಂದು ಕಷ್ಟದ ಕೊಡುದಿಲ್ಲ. ಗಾಸ್ ಎಲಿಮಿನೇಷನ್ ಮಾಡಿ ಯಾವ್ದು ಒಂದು ಮಾಡಿ 3/3 ನೇ ಕೊಡುದು, 4/4 ಕೊಡುದಿಲ್ಲ. ಏನಿದ್ರು ಬೇಕು 4/4 ಕೊಟ್ಟರು ಅದು ಸುಲಭದಲ್ಲಿ ಕೊಡ್ತಾರೆ. ಸಮ್ ಆಫ್ ದೆಮ್ ವಿಲ್ ಗೋ ಟು 0, ಎಲಿಮಿನೇಟ್ ಅಂತದ್ದೇ ಕೊಡ್ತಾರೆ. ತುಂಬಾ ಕಷ್ಟ ಕೊಡುದಿಲ್ಲ, ಕಷ್ಟ ಕೊಟ್ಟಾರೆ, ಆದ್ರೆ ಇಟ್ ವಿಲ್ ಬಿ ಕಾನ್ಸೆಪ್ಚುಯಲ್. ಸರಿಯಾ? ಬರತ್ ಅರ್ಥ ಆಯ್ತಾ? ಐಗನ್ ವೆಕ್ಟರ್ ಇದು ಡಯಾಗ್ನಲ್ ಇದು ಮಾತ್ರ, ಡಯಾಗ್ನಲ್ ಮಾತ್ರ ಮೈನಸ್ ಮಾಡ್ಬೇಕು. ಯಾಕೆ ಡಯಾಗ್ನಲ್ ಮೈನಸ್ ಮಾಡಬೇಕು? just see what is explained here again. What is this? A minus lambda I. Lambda is the value, minus I. Diagonal ಮಾತ್ರ minus I. ಸರಿಯಾ? ತುಂಬಾ ಚಂದ ಆಯ್ತು ಇದು, ನಂಗೆ ಖುಷಿ ಆಯ್ತು ಇವತ್ತಿದು. So using that you get, so 250 is the ಸಿಗುದಿಲ್ವಾ? 3x3 is equal to 0. x3 is 0. Okay. Then here this one. Okay. So you get x3 is 0. So here we get x2. ಇಲ್ಲಿಂದಲೇ ಮಾಡುವ. x2 x3 is 0. ಹೌದಾ? ಇದು ತಪ್ಪಾಗಿದೆ, ಇದು ಸರಿ ಆಯ್ತಾ? ಇದು 2 minus 2 x2 is equal to ಎಷ್ಟು ಬರುತ್ತೆ? ಮಾಡಿ ನೋಡ್ಬೇಕಾಗುತ್ತೆ ಈಗ. ಇದಕ್ಕೆ ಡೈರೆಕ್ಟ್ ಬರುದಲ್ಲ. x3 0 ಬಂತು, x2 0 ಬಂತು. ಅಲ್ಲ ನೋಡಿ, 3x3 should be equal to 0. x3 ಯಾವುದೇ ವ್ಯಾಲ್ಯೂ ಬರ್ಬೋದು. ನೆಕ್ಸ್ಟ್ x2 is equal to 1 into x2 should be equal to 0. Sorry, second one, ಈ equation ಇಂದ ಏನು ಬರುತ್ತೆ? Sorry, all the three equation you see. Now we have to see which of these will satisfy this equation. For example, the equation is 3x1 minus 2x2 plus 2x3. Then 0x1, 0x2, 1x3. 0x1, 0x2, 3x3. ಈ ಎಲ್ಲ ಈಕ್ವೇಶನ್ ಸ್ಯಾಟಿಸ್ಫೈ ಮಾಡೋದು ಯಾವುದಿದೆ ಇದರಲ್ಲಿ? ಯಾವ್ದು ಬರುತ್ತೆ? 3 into 3, ಓಕೆ, ಪ್ಲಸ್ minus 2 into minus 2. ಇದು ಮಾಡುವ ನಿಮ್ಗೆ ಬರುತ್ತಾ? ಬರಲ್ಲ. ಇದು ಬರಲ್ಲ, ಇದು ಬರಲ್ಲ, ಇದು ಬರಲ್ಲ, ಇದು ಮಾತ್ರ ಬರುವಂಥದ್ದು. ಚೆಕ್ ಮಾಡಿ ನೋಡಿ. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಇಲ್ಲಿ ನೋಡು, 3 into x1 is 3 minus 2 into minus 2 plus 2 into 1 ಎಷ್ಟು ಬರುತ್ತೆ ಆನ್ಸರ್? 0 ಬರುತ್ತಾ? ಬರುವುದಿಲ್ಲ. ಕರೆಕ್ಟಾ? ಎಷ್ಟು ಬರುತ್ತೆ? 5 ಬರುತ್ತೆ. ಇದು ಏನಾಗುತ್ತೆ? 3 into 1 ಯಾವ್ದು ಇದಾ? ಲಾಸ್ಟ್ ಇದು ಇಂಪಾರ್ಟೆಂಟ್. ಇದು 5 ಬರ್ಬೇಕಾ? ಹಾ ಕರೆಕ್ಟ್ 5 ಮೈನಸ್ ಆಫ್ ಯಾ. ಸೊ ಇದು ಆನ್ಸರ್ ಕರೆಕ್ಟ್ ಬರ್ತದಾ? ಇಲ್ಲ, ಇಲ್ಲಿ 0 ಬರುದಿಲ್ಲ, ಇದು 0 ಬರುದಿಲ್ಲ, ಇದು 0 ಬರುದು, ಇದು ಮಾತ್ರ 0 ಬರುತ್ತೆ ನೋಡಿಬೇಕು. ಸೊ ಅದಕ್ಕೆ ಅದು ಆನ್ಸರ್. ಅರ್ಥ ಆಯ್ತಾ? ಇಲ್ಲಿ ಇದನ್ನು ಬೇಕಿದ್ರೆ 4 10 0 ಮಾಡಿದ್ರು ಆನ್ಸರ್ ಬರುತ್ತೆ. ಮಲ್ಟಿಪಲ್ ಲೀನಿಯರ್ಲಿ independent and dependent. Okay. Cayley Hamilton theorem states, okay, these things you can do. Okay. Matrix A satisfies. ಇದೊಂದು ಈಕ್ವೇಶನ್ ಇದೆ, ಡೈರೆಕ್ಟ್ ಆಗಿ ಕೊಟ್ಟು ಬಿಟ್ಟಿದ್ದಾರೆ ಅದರಲ್ಲಿ ಎಲ್ಲ ಇದರಲ್ಲಿ. ಆಯ್ತಾ? ನಾವು ಇದರಲ್ಲಿ ಯಾವುದು ಸ್ಯಾಟಿಸ್ಫೈ ಆಗುತ್ತೆ ಅಂತ ಕೇಳಿದ್ದಾರೆ. 3 minus lambda ಇದು ಮಾಡಿ ನೋಡಿ, ನೀವು ಆನ್ಸರ್ ಇರುತ್ತೆ. a power 9 equals to, ಇದನ್ನು ಒಂದ್ಸತಿ ನೋಡಿ, ಈಸಿ ಇದೆ ಅದು ಕ್ಯಾಲಿ ಹ್ಯಾಮಿಲ್ಟನ್ ಥಿಯರಂ. ಸರಿ, ಹಾಗಾದ್ರೆ ಸೊ ಐ ಥಿಂಕ್ ಆಲ್ಮೋಸ್ಟ್ ಎವ್ರಿಥಿಂಗ್ ಇಸ್ ಡನ್ ಇನ್ ಸೊಲ್ಯೂಷನ್. ದ ನಂಬರ್ ಆಫ್ ಕ್ವೆಶ್ಚನ್ಸ್ ವಿಚ್ ಆರ್ ದೇರ್. ಪ್ರಾಪರ್ಟೀಸ್ ಆಫ್ ಡಿಟರ್ಮಿನೆಂಟ್ಸ್ ನಿಮಗೆ ಈಸಿ ಇದೆ, ನೀವೇನು ಹೆದರಬೇಡಿ, ಸುಲಭ ಉಂಟು, ಮಾಡಬಹುದು. ಆಯ್ತಾ? ಸೊ ದೀಸ್ ಆರ್ ಇಂಪಾರ್ಟೆಂಟ್ ಒನ್ ಸ್ಟೂಡೆಂಟ್ಸ್. ವಾಟ್ ಎಲ್ಸ್ ಡಿಡ್ ವಿ ಡೂ? ಫ್ಯಾಕ್ಟರ್ ಥಿಯರಮ್ ಎಲ್ಲ ಮಾಡಿದ್ದೇವೆ, ಇದೆಲ್ಲ ಬೇಡ ಅಷ್ಟೊಂದು. ಆಯ್ತಾ? ಡಿಫ್ರೆಂಟ್ ಟೈಪ್ಸ್ ಆಫ್ ಮ್ಯಾಟ್ರಿಸಸ್ ಎಟ್ ದ ಎಂಡ್ ಮಾಡಿದ್ದೇನೆ, ಇದನ್ನ ನೋಡಿ, ಇದನ್ನ ಒಂದ್ಸತಿ ನೋಡಿ. ಡಿಫ್ರೆಂಟ್ ಟೈಪ್ಸ್ ಆಫ್ ಮ್ಯಾಟ್ರಿಸಸ್, ಸಿಮೆಟ್ರಿಕ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಅಂದ್ರೆ ಎಂಥದ್ದು, ಸ್ಕ್ಯೂ ಸಿಮೆಟ್ರಿಕ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಅಂದ್ರೆ ಎಂಥದ್ದು, ಒಂದ್ಸತಿ ನೋಡ್ಕೊಳ್ಳಿ ಅಷ್ಟೇ. ಆಯ್ತಾ? ಸಿ ಇನ್ನೊಂದು ಇಂಪಾರ್ಟೆಂಟ್, ಐಗನ್ ವ್ಯಾಲ್ಯೂಸ್ ಆಫ್ ಎ ಸಿಮೆಟ್ರಿಕ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಇಸ್ ಆಲ್ವೇಸ್ ರಿಯಲ್. ಸಿ ಇದೊಂದು ಪ್ರಾಪರ್ಟಿ, ಇದೊಂದು ಪ್ರಾಪರ್ಟಿ, ಐಗನ್ ವ್ಯಾಲ್ಯೂಸ್ ಆಫ್ ಸಿಮೆಟ್ರಿಕ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಇಸ್ ಆಲ್ವೇಸ್ ರಿಯಲ್. ಐಗನ್ ವ್ಯಾಲ್ಯೂಸ್ ಆಫ್ ಸ್ಕ್ಯೂ ಸಿಮೆಟ್ರಿಕ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಇಸ್ ಆಲ್ವೇಸ್ ಇಮ್ಯಾಜಿನರಿ. ಇದು ನೆನಪಲ್ಲಿ ಇರಲಿ, ಲಾಸ್ಟ್ ಮಾಡಿದ್ದೇನೆ. Next, if eigenvalues of matrix is real, then it does not mean the matrix is symmetric. Okay? If it is symmetric, it's orthogonal. Orthogonal transformation ಇದು ಮಾಡಿದ್ದೇನೆ ನಾನು, ಕರೆಕ್ಟಾ? ಸೊ ಸಾಕು ಇಷ್ಟು. ಬಾಕಿದೆಲ್ಲ ಕಾಂಪ್ಲೆಕ್ಸ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಮಾಡಿದ್ದೇನೆ, ನೋಡಿ. ಯು ಕ್ಯಾನ್ ಸಿ ಇಟ್ ಒನ್ಸ್. ಬಂದಿತ್ತಾ? ಸೊ ಇದು ಈಸಿ ಇದೆ, ಮಾಡಿ ನೋಡಿ ಒಂದ್ಸತಿ. ಆಯ್ತಾ? ಐ ಥಿಂಕ್ ಕ್ರಾಮರ್ಸ್ ರೂಲ್ ಒಂದಿದೆ, ಈಸಿ ಇದೆ, ಸುಲಭ ಇದೆ. ಅದು ಜಾಸ್ತಿ ಬರುವುದಿಲ್ಲ, ತುಂಬಾ ಕಮ್ಮಿ ಬರುತ್ತೆ. 1 ಮಾರ್ಕಿಗೆ ಒಂದು ಕ್ರಾಮರ್ಸ್ ರೂಲ್ ಇದು ಬಂದಿದೆ, ಯು ಕ್ಯಾನ್ ಸಿ ಇಟ್. ಓಕೆ, ಎಲ್ಲ ಕ್ವಶನ್ಸ್ ಮಾಡಿದ್ದೇನೆ, ಎಷ್ಟೋ ಕ್ವಶನ್ಸ್ ಮಾಡಿದ್ದೇನೆ. ಸೊ ದಟ್ಸ್ ಇಟ್, ದಿಸ್ ಇಸ್ ಇನಫ್.